Hello and welcome back to another video covering concepts seen in the ACT Math section early on. In this video we're going to cover solving systems of equations using either substitution or elimination. Just like all the other videos, if you find it helpful, leave a like, subscribe if you want to help me out, see when I post more videos, or help others find the channel. And feel free to comment with anything you like, anything you'd like to see more of or done differently, or anything that's giving you trouble, and maybe I can try and make an extra video specifically for that. But let's get started. So let's begin with what am I talking about when I say a system of equations. That's where I have two different equations, both with two unknown variables. Typically that's x and y, but they can be whatever letters they choose, a and b, but almost always it's x and y. And I have two options on how to solve them, which will give you a little hint as to what those are on the first slide. That's substitution, which is where I'm going to solve one of those equations for one of the variables, and then plug that into the other equation, or elimination, where I'm going to add those two equations together to eliminate one of the variables, but that does sometimes require some setup. I'll go into more detail in the next slides on how to do all of these. But I just want to point out that both ways work. Whichever one you want to use, it's purely a matter of preference, whatever you find easier. There are some scenarios where I find substitution's easier, others where I find elimination is easier. I'll try and point out when those are, but either will work in any situation. So let's begin with substitution. To do this, we're going to solve one equation for one of the variables. We're not going to get all the way to a number answer, but we'll get another expression. Then we're going to plug that expression into the second equation. And that will leave that equation with just one unknown, and we'll solve that one for whatever that one variable is. Then, if we needed to know what that other variable was, or if we needed to know what both the answers were, we can plug the answer we just got into that first equation that we used at the beginning time and solve for the other of the variables. The advantage here is that there's no setup necessary. You just start solving right off the bat. The disadvantage is that you're more likely to create math with fractions if that first equation can't really be solved easily to get a nice clean expression. Again, either will work. So it tends to be easiest if one of those variables just has no coefficient, so no number in front of it, or if you can't find an easy way to set up elimination. So let's take a look at an example of a system of equations solved with substitution. And then later I'll solve this exact same set with elimination to show you can do it both ways. So here we have two equations, 2x plus y equals 12 and 3x plus 2y equals 16. Now the first thing I notice is that this y here has no coefficient, so there's no number in front of it. So that tells me I can pretty easily solve for y. When I say solve for y in a case like this with two unknowns, I just mean get it by itself. So it would be y equals stuff. And I can get that pretty easily because I don't have to worry about dividing by anything. I would just have to subtract the 2x from both sides. So that's what I'm going to do. So like I just said, that first equation here has nothing in front of the y, so it's going to be easy to solve just for y. You could also solve for the x if you wanted. You could solve this for one of the others. It doesn't matter. It's just that would be a little harder because let's say you wanted to solve for this x and put it by itself. You could. You'd have to subtract by 2y and then you'd have to divide by 3. But that's going to make fractions because then you'd have x equals 16 over 3 minus 2/3 y. And I don't like dealing with fraction math if I don't have to. So that's what I was talking about where I say you're more likely to end up with fraction math with substitution. But anyways, let's do the easy one like I said. Get this y by itself. I'm going to subtract the 2x from here and over here. And that gives me y equals 12 minus 2x. So now this is from this equation, and I've still got this one. The next thing you do is you're going to plug in this solved y to the second equation. And make sure you go to the other one, because we used this one to get this, so I have to take this and plug it into the other. So where I have a y, I'm now going to put this 12 minus 2x. And that gives me this. So again, I still have that 3x plus 2, and then where I had a y, I'm going to put this in parentheses. 12 minus 2x equals the 16 from here. And now I can just solve this one for x. So the first thing I did here is I have to distribute this 2 into the parentheses. So if you don't remember how to do that, you just have to multiply the 2 by everything in here. And luckily it's positive 2, so there's nothing complicated. Be careful. If this said minus 2, you have to multiply everything in here by negative 2. But that's not the case here. So I have 3x plus 2 times 12 is 24, minus, because 2 times negative 2 is negative 4, so minus 4x equals 16. Now I have two x terms, so I'll combine them. 3x minus 4x is going to give me negative x, and then I still have plus 24 equals 16. Now I'm going to subtract the 24 from both sides. That gives me negative x equals negative 8, or x equals 8. So there we go. We have the x value. So, important thing to point out here, if the question's only asking you for x, you're done. It's 8. You don't need to worry about solving for y. But if they're asking for y, or sometimes the ACT will do a weird thing like, well then, here's my system of equations, so then what would x plus y be? In which case, you just have to solve for x and y, and then you can add them together. So if that's the case, we've got x, we need to solve for y. So we can take this 8 and we can plug it back into either one of these equations. I went back into the first one, so where I see x, I'm just going to put an 8. So 2 times 8 plus y equals 12. Again, it's just this equation, but I put an 8 in there for x. And I can solve this for y. So that 2 times 8 gives me 16. So I still have my plus y equals 12. Then I'm going to subtract 16 from both sides, giving me y equals negative 4. So that would be my answer. X is 8 and y is negative 4. So that's it for substitution. Now let's go look at elimination and how to solve those. So for these, you're going to have a little bit more setup. So you're going to have to take one of those equations, because remember you're given 2, and you're going to multiply the entire equation by a constant. So just pick a number, and you're going to have an objective here, which I'll explain in a second. But keep in mind that number you multiply it by might be negative. You might have to make it negative. Because your goal is to get one of those variables, so either x or y, to have the exact same coefficient, or that number in front of it, in both of the equations, but with opposite signs. For example, if I have negative 3x in one equation, I want to have positive 3x in the other equation. They both have 3 in front of the x, but one's negative and the other is positive. That's what we're trying to do. So once you have that, you can then add the two equations. And the nice thing is, and the reason we did this, is then when you add them, negative 3x plus 3x, you get 0. So that entire variable just goes away, or it's eliminated, which is where the name comes from. And then, since one of those is gone, you can just solve what's left over for the remaining variable. And then, as with substitution, if you need to plug back into either of those equations to get the other variable, you can do so. So the advantage of elimination is it tends to lead to very easy math after you set up those equations. The downside is you have to set up those equations. If you can do that easily, that's awesome. But sometimes when you have large numbers or weird numbers, that's not always so easy, and then you might be better off with substitution. So in general, this tends to be the easiest if there's just one variable that you can easily see a way to get those equal but opposite coefficients. But again, I just want to stress you can always do it with substitution, or you can always do it with elimination. It's really up to you and what you like in each situation. So let's solve this exact same example we did earlier with substitution, and now we're going to do it with elimination. So here, I'm again going to focus on this y variable. The reason is because I have a y and a 2y, so it would be pretty easy to get equal and opposites if I just multiply this whole equation up top by negative 2. Because then I'd have negative 2y and positive 2y. So I'm going to do that. So again, here's my first equation, the 2x plus y equals 12. I'm going to multiply everything here by negative 2. So that 2x becomes negative 4x, plus y becomes minus 2y, 12 becomes negative 24. So this is my new first equation, and I still have my second equation. And now I add them. So I'll take this here, and then I rewrite the second equation here, and I'm going to add. So I'll just go one at a time here. Negative 4x plus 3x is going to give me negative x. Negative 2y plus 2y gives me 0, so y is eliminated. And then negative 24 plus 16 is going to give me 8. So, as I just said, negative x, the 2y is gone, equals negative 8. Or x is 8, which remember is the exact same answer we got with substitution. So as you can see, this math got really easy. After I added them, I didn't really have to do anything. It's pretty much solved itself. That's the beauty of elimination. The challenge is getting to this part here, and that does take some practice. But just like before, if the question's only asking for only asking for x, I'm done. But if I need to find y, we can go back and plug into either one of these equations and find y. So we can do the exact same way we did last time. Take that 8, put it into the first equation right here to get 2 times 8 plus y equals 12, or 16 plus y equals 12, or y equals negative 4. Sorry, I went pretty quick there, but it's the exact same thing we just solved 2 slides ago. And that's all there is for substitution and elimination. Do look up some practice for these, because I can almost guarantee you're going to have a problem or two on the ACT with these, so you want to get used to them. They're not too bad, but they are a little odd if you haven't done them before. Good luck, and I'll see you on the next one.